Exponential modeling can be used to describe many real-life applications. And we're going to start with the base formula, y equals a times b to the x over p. A is always your starting amount. B is your growth or appreciation factor, or your decay or depreciation. It depends if something is going up or down. It's basically your multiplier, and I'll talk more about that in a second. P is the period, so how long it takes for one either growth period or decay period to happen. So if we look at this question, a colony of insects doubles. So if something is doubling, I have to multiply it by 2. So that's my growth rate. It's doubling or growing by a factor of 2 each time. That'll be my B. Every 20 days. That means it takes 20 days to double once, so that's my period. That's going to go in for P. It starts with 25. A is always your starting number. So then find an expression means I'm going to take this formula, fill in 25 for A, 2 for B, and then x over 20 as my exponent. It's important to keep this x over 20 looking like an exponent because it is the exponent. Now when it says how many will there be in 60 days, that means I'm going to sub in 60 for x. There's an implied bracket in this exponent. You have to calculate it first. So I'm going to do 60 divided by 20, which works out nicely. It gives me 3. Now order of operations says I do exponents before multiplication. Depending on your calculator, you might just be able to type this in as you see it. 25 times 2 to the exponent 3. I'm going to do it in my head this way to make sure. 2 to the exponent 3 is 8. That's 2 times 2 times 2. 8 times 25 is 200. So in 60 days, there will be 200 insects in that colony. For 7 months, here's where I have to be careful because my period is in days. 7 months, it's not going to be exact, but I'm going to say, well, there's an average of 30 days per month. So 7 months is really 210 days. I went 7 times 30. I can't put the 7 in for x because that would be for 7 days, not 7 months. So I convert it to an approximate number of days, so 210 divided by 20. I'm going to do the 210 divided by 20 first to make sure I get my right exponent. You can type it in all at once as long as you know how to use your brackets, but that gives me 10.5. And now I'm going to do 25 times 2 to the exponent 10.5. The 10.5 only goes with the 2, but my calculator understands that. So I'm going to round up because you don't have decimal of a bug. So it's approximately 36,204 after 7 months. 1 year, I start with my base function. Everything is the same except this top. 1 year is 365 days, so I have to put 365 in. If I put 1 for the year, it'll think I just mean 1 day. I'm do 365 divided by 20, 18.25. And then I type it into my calculator. So 7,793,588. I just threw the commas in. You don't need them, but it helped me figure out what unit this 7 was in front, that actually was a millions. Sometimes in the answers you might see something like approximately 8 million because they will round. So now we're going to look at a painting that originally sold for $2,000 in 1996. So that's my starting amount. Okay, it just resold for $510. That's my answer. That's my Y in 2014. Find an algebraic equation that models the appreciation. Appreciation is something going up in value, and we understand that the period for appreciation or depreciation, if you're talking about cars, is understood to be 1 year to make it easy, because now y equals a times b to the x over p becomes x over 1, or just a times b to the x, because our period or our unit is a year. I do need to figure out what x is though. It sold in 1996 and then again in 2014. So I'm going to subtract to figure out how many years are between that, and I believe it's 18. I'm just going to double check. So that's been 18 years. Now I'm going to solve for my b. So instead of subbing in a and b and x and figuring out an answer, I know my answer is 510,000 when I started at 200,000, grew by some appreciation rate for 18 years. So I'm going to take the 200,000 over and divide. 510,000 divided by 200,000 gives me 2.55. And so I'm left with b to the 18. Now, the opposite of exponent 18 is 18th root. Now, that can be kind of hard to find your any root. It's not 18 times the square root. Some people will still just use that and put an 18 in front of it. That doesn't work. The easiest way to type this in is with your exponent key and either do 1 over 18 if you have a fraction key, or just 1 divided by 18. Because remember, our law for exponents says if you have a fractional exponent, 1 on top, 18 on the bottom, that's the same as the 18th root. So in my calculator, I'm going to go 2.55 to the exponent, bracket 1 divided by 18, and I get 1.05338, but I'm going to leave it at that. So now, when we talk about appreciation or depreciation, we talk about percent. I can see that this is an appreciation because 100% is consistent. Anything higher than 100% is an appreciation. So this is growing by 5% because 1.05 is 105%. So the appreciation rate is 5%. If I solved this question and I got something lower, let's say I got 0.80 equal to b, well that, if I compare it to 100%, is lower, so this would be depreciation. And it would be a 20% depreciation because of the fact that 80% is 20% less than 100. But still, b is 1.05 because now if I say y equals 200,000 times 1.05 to the exponent x over 1, when it asks me for 10 years, well, 10 years is going to be 2024, or add 10 years to the 18, and it'll be 28 years. So this is 200,000 times 1.05 to the 28, and I asked my calculator for that answer. So $784,025.83. Now